Alright, so we're going to start chapter 4 today, and that is about solving systems of linear equations. And the whole chapter is about different ways to solve these systems of linear equations. So just know that basically we're going to be learning like 4 different ways in order to solve these. And what this means is that you're given 2 lines, and we want to see where these 2 lines cross. Where's their meeting point? So like for example, if you were to graph your income, so hopefully that would be like a positive slope line or something that's your income throughout the month, and then your expenses, which takes all your money away, so that would be like a negative slope going. Well, where's that equal point? Where are you breaking even, I guess, that one point where those 2 lines would possibly cross. And if you're running a business, think about your expenses versus the income that you make off whatever product that you're selling. We want to make sure that we're in the positive range whenever we're doing that, but we have to know the point where we break even so that we know where our profit is or whether we're losing money in our business. So that's what these are for, that each one of these lines would represent something, and we just want to see where the 2 of them meet or where they cross, and that is the solution to the system of our linear equations that we're given. So the first way today, we're going to learn 2 different ones, and the first one is just we're given a point, and is that point a solution? So in this case, for the example, it says determine if the following ordered pairs are solutions to the system of equations. Well, here we're given 2 of them. So for part A, we want to know, is 1, 2 a solution? Well, we know every ordered pair is an xy. So x is 1 and y is 2. So all we're going to do is plug the x in for the x value and the y in for the y value, and we're going to see if these 2 satisfy this equation, both of these equations. So we're given these 2 equations. 2x minus 3y is equal to negative 4. Our other equation is 2x plus y is equal to 4. Well, we're just going to go stick in the x value for 1 for the x value and 2 in for the y value. So 2 times x, which is 1, minus 3 times y, which is 2, is that equal to negative 4? Well, 2 times 1 is 2, and 3 times 2 is 6, so 2 minus 6, is that equal to negative 4? Well, yes it is. So it works for that one, but it has to work for both of them in order for it to be a solution. It can't just work for one of them, because it's got to be a solution to the system, so both of them. So let's see if it works on the other one. 2 times x, which is 1, plus y, which is 2, is that equal to 4? 2 times 1 is 2, plus 2, I don't know why I put that there, is equal to 4. 4 is equal to 4. So yes, 1, 2 is a solution. All right, so now let's go look at part B. Is 7, 6 a solution? Well, in this case, our x is going to be 7. Our y will turn to be a 6. And we'll see if this ordered pair works. All right, so let's write our 2 equations. 2x minus 3y is equal to negative 4. And 2x plus y is equal to 4. All right, so now we're just going to fill in this particular ordered pair. So remember, this is just like 2 separate questions in part A and part B, so they don't have anything to really do with each other other than the same system of equations. So x is 7, y is 6. 2 times x, which is 7, minus 3 times y, which is 6, is that equal to negative 4? Well, 2 times 7 is 14, minus 3 times 6, which is 18, is that negative 4? 14 minus 18 is negative 4, and that is equal to negative 4. So it works in that one. Let's see if it works in the other one. 2 times x, which is 7, plus y, which is 6, is that equal to 4? 2 times 7 is 14, plus 6, is that equal to 4? Well, 14 plus 6 is 20. Is that equal to 4? No, it is not. So 7, 6 is not a solution. And we can write it down here. And so I think that is exactly what your My Math Lab will say. It's not a solution, or it is a solution, you know, like that. So you'll just either have to check yes or no. So some may be, some may not, but notice they have to be a solution to both of the equations in order for it to be a solution to the system. So that's all it is. That's all you have to do when it's an ordered pair that's given to you to find a solution. Now the second way we're going to solve a system of equations is by graphing. So we're going to have to graph both equations in the same coordinate grid. So we're given two equations. We know the best way to graph that is to put each equation in y equals mx plus b in order to graph. And then we're going to graph them both in the same coordinate system, and we're going to see where those points intersect, where they cross. So let's do this as an example. I'm going to do each one. So here we've got the equation 2x plus y is equal to 6. And I'm going to do one equation at a time, and then I'll do them in two different colors here so that we're graphing both of them, and you can tell which is which. All right, so we're going to do pink over here first. Well, remember, we have to put them in y equals mx plus b format first. Okay, so we've got to subtract our 2x on both sides, and that gives us y is equal to negative 2x plus 6. Okay, so remember in that y equals mx plus b format, the b term, let me just do this in a different color, y equals mx plus b. B is that y-intercept where it crosses the y-axis. M represents the slope, and remember that's that rise over run. So in this case, we have a y-intercept at positive 6. So the y-intercept is at 6. My slope is at negative 2. So we're going to start at positive 6 on the y-axis, which is right there. Okay. Then we've got that slope of negative 2, and remember that's negative 2 over a positive 1, and I can work that both ways. Now if you're doing this, you need to make several points on here, so on your coordinate grid, so that you know exactly where these points are. There's no guessing at where these points are, because you've got to know the exact point where these two lines are going to cross. So we're going to go down 2 from that 6, the y-intercept, over 1, positive 1, down negative 2 over positive 1, down negative 2 over positive 1, and I'm going to make several points on here so that I know exactly where all these points are, so that we know where this line's going to cross. I can also go positive 2, negative 1. Just remember that. Okay, so there is my first line, and I know this makes a very thick line when I try to draw it, so I'm going to be very careful here. Okay, there's the first line. So now we've got to go do the same thing for the second line. So we've got to put it in y equals mx plus b. So we're going to subtract 2x from both sides. So that gives us negative y is equal to negative 2x minus 2. I need to get rid of that negative, so I'm going to divide by negative 1. So y is equal to positive 2x plus 2. All right, so this one, we have our y-intercept is at positive 2, and we also have a slope that's at 2, positive 2. All right, so we're going to graph our y-intercept first, which is at positive 2. We know that that's a point on our line. Then we have a slope of 2. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1. We're going to keep doing that. Remember, we can also go the other way. But we already see the point where those two lines cross. All right. So they cross at this point right here. So what is that ordered pair? That ordered pair where they cross is at, remember x value is first, so we're going over 1 and then up 1, 2, 3, 4. So 1, 4 is the solution. And that's how you would label it. So our solution here is at 1, 4. And you can go put that back into the original equations using your 1 for x, your 4 for y, and that should make both of those equations true. If you want to go check your answer, that's a really smart thing to do so that you know for sure you've got the correct one. And watch those points when you're graphing. All right, let's try another example. We're going to solve this one by graphing also. So we're given two equations. Y is equal to negative x plus 6. This one's nice and pretty. We don't have to go solve for our y and put it in y equals mx plus b format because it's already in y equals mx plus b format for us. And so we're just going to have to go graph. So remember here, again, your y-intercept is at 6. And what's our slope here? Negative 1. And so remember, any whole number is always over over a 1. So that'll be negative 1 over 1. So first we'll start with our y-intercept. Is it positive 6? And then we have a slope of negative 1, which means I go down 1. That takes care of the negative over positive 1. Down 1 over positive 1. And just, if you have trouble with that, I know several times we have, people will do negatives or whatever. Just remember, that's got a negative slope, so this line should be pointing down. And so that's always another good check to just make sure it's pointing in the right direction as our, whatever our slope is, positive or negative. So it's a negative slope, so it's pointing down. All right, let's go graph the other one. This one has a y-intercept at negative 6, and it has a slope of 3, which is always over 1. Any whole number is over 1. So let's see, we're going to start at the y-intercept down here at negative 6 on our y-axis, which is right there. And then we have a slope of 3. So we're going to go up 3 over 1. Up 3 over 1. Up 3 over 1. And there's our point of intersection. So we're going to mark that. So what is that ordered pair? Well, we are at 1, 2, 3 on the x-axis and then up 3 on the y-axis. So that is the solution to this system of equations is at 3, 3. So you can always go back and check. You have 3 as your x value, 3 as your y value. Make sure you put those in and you can check and make sure. Okay, well, would there ever be a point where these two lines might not cross? Or would there ever be a point where these two lines might have, more than one solution? Well, what would make these two lines not cross? What two kind of lines don't cross? Well, if we have parallel lines, we know those two never cross. So we can look at these also. So we're going to graph each one of these. So y is equal to 3x minus 2. We're going to do that one in green. So again, our y-intercept should be at that negative 2. Hopefully you're getting the hang of graphing these. Then we have a slope of 3. which is 3 over 1. So we're going to rise up 3 units, run over 1 unit, rise up 3 units, run over 1 unit, rise up 3 over 1. And I can also go -3, -1, because that's the same thing. Actually, hopefully, you'll agree with me if I say -3 over -1. Is that the same thing as +3 over +1, which is just 3? Yes, it is. Negative divided by negative is a positive. So that's how we can make sure we go both ways on that. All right, the other one is y is equal to 3x plus 1. All right, y-intercept is at +1. So we're going to go make that point. And then we have a slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1, down 3 over 1. Well, notice that these two lines are never even getting close to each other. They're always staying that 1 unit apart. So they are never going to cross. So they are parallel lines. And so parallel lines are never going to cross. So there is no solution. At no point are these two lines going to cross and create something. Now we can also just look at this, and once we solve for this and we say, oh, well, they do have the same slope, so there is no solution there. All right, so we're going to do another one here. All right, well, these are not in y equals mx plus b format, so we're going to have to go put them in. So x plus y is equal to 3. All we have to do is move that x over. And remember, we talk about getting in that habit of putting that x value first so that we don't get our y-intercept and our slope mixed up. So on this one, we're going to have our y-intercept at +3. And then we have a -1 slope. So down 1 over 1, down 1 over 1. Okay. So we've graphed that one. Next, we're going to graph our 2x plus 2y is equal to 6. We'll subtract our 2x from both sides. So it gives us 2y is equal to -2x plus 6. Divide everything by 2. So y is equal to -x plus 3. Well, notice we came up with the exact same equation. Well, if we come up with the exact same equation, these two are going to be the exact same thing. So every point along here is a solution. So in this case, we say we have an infinite number of solutions because they are the exact same line, and every point on that line is a solution. So that is graphing a system of linear equations.